Never think of Jupiter as just a big striped ball. Think of it as the engine that quietly runs the solar system, and the reason Earth looks the way it does. Here's the idea I want to put in your head right now. If Jupiter were missing, our night sky, our weather, maybe even life on Earth could be very different. Most people know the red storm and the bands, but the real story is deeper, hotter, stranger, and much more important. By the time we're done, you'll see why Jupiter isn't just the biggest planet. It's the boss. Jupiter is the first planet that makes you say, wow, through a small telescope. A clean, bright disk, bands like faint road lines, 4 little dots in a row, Io, Europa, Ganymede, and Callisto. Galileo saw those dots in 1610 and realized something bold for that time. Not everything goes around Earth. Those tiny moons started a new way of thinking. They are still doing that today, but hold that thought. We'll come back to the moons, because they are half the story. Let's build a clear mental picture. Jupiter is huge, more than twice as massive as all the other planets put together. You could line up a bit over 11 Earths across its face. It spins fast. A day is just under 10 hours. It takes almost 12 Earth years to go around the Sunday. It's made mostly of hydrogen and helium. That's the same mix stars use. Jupiter didn't take enough to shine like a star, but it took enough to act like one in some ways. That matters for heat. It matters for magnetism. It matters for the weather. And it matters for us. So what's the problem with the simple school version? The common picture is a neat layer cake. Thin air on top, thicker gas below, then a liquid layer, then a small solid core at the middle. Nice and tidy. The truth is messier and more interesting. When we measured Jupiter's gravity field up close and watched how it spins, we found signs that its core is not a hard ball. It's more like a fuzzy zone rich in heavy stuff that blends into the layer above. Jet streams don't just run on the surface, they go deep. Lightning strikes in places that never see ground. There may even be mush balls, little pellets made of ammonia and water, falling like slushy hail through the storms and melting deeper down. The more we looked, the more the tidy cake fell apart. And when tidy pictures fall apart, better understanding shows up. To understand Jupiter, we have to go back to the beginning. Picture the newborn sun, wrapped in a thick disk of gas and dust. Close to the sun, it's hot and dry. Farther out, it's cold and full of ice. In that cold zone, small pieces stick together, then grow fast. Once a baby planet gets big enough, it pulls in gas like crazy. That's how a giant grows. Jupiter grew early, and it grew fast. It grabbed so much gas that it became the heavyweight of the whole system. When a planet gets that massive, it does not just sit there. It rearranges the furniture. It opens gaps in that birth disk. It changes the orbits of rocks and ice. It can drift a bit inward and then back out, or wobble in place and still shove other stuff around. However it moved, its gravity shaped the map of what was possible for all the other planets. This is not a side note. This is the main plot. Jupiter helped decide where water ended up, what got smashed, what survived, and where Earth could form and keep a safe distance from trouble. Inside Jupiter, hydrogen goes through a strange change. Up here, at Earth-like pressure, hydrogen is a gas. Deep inside Jupiter, the squeeze is beyond anything you can imagine. Under that pressure, hydrogen turns into a liquid that acts like metal. Electrons can move the way they do in a wire. That metallic hydrogen is the heart of Jupiter's power. It drives a magnetic field so strong that it makes Earth's field look small. That field traps high-energy particles and builds radiation belts that are brutal for spacecraft. It also stirs up brilliant auroras over Jupiter's poles, far brighter than our northern lights. Above that metallic layer is a deep envelope of molecular hydrogen mixed with helium and a little water, methane, and ammonia. Here's another odd thing. Helium does not always stay mixed in. In some layers, helium can form drops and fall like rain. Helium rain. As those drops fall into deeper, hotter layers, they release energy. That's one reason Jupiter shines in infrared and gives off more heat than it gets from the Sunday. It is still cooling from its birth. It is still settling. That extra heat feeds the weather, and the weather never rests. Now look at the outside. The band's light zones and dark belts are not just pretty stripes. They are wide, high-speed jet streams wrapped around the planet. The light zones are where gas is rising. The dark belts are where gas is sinking. Those flows are stable enough to last for years, yet they change too. A belt can fade and then roar back. Colors shift as the chemistry changes. Sunlight and charged particles break apart molecules near the top. New ones form. Many of those new molecules are reddish or brown. That is part of the reason Jupiter is not just white and grey. It's painted by chemistry, and the painting keeps changing. And then there is the Great Red Spot. It's not a dot. It's a huge high-pressure storm with winds faster than any hurricane on Earth. It has lasted for centuries, though the exact size has changed. Lately, it has been shrinking, but it remains larger than our whole planet. It is like a slow, deep whirlpool, an eddy in a sea of jet streams. How does it live so long? Jupiter has no land to tear it apart. The heat from below keeps feeding the atmosphere, and the jets around it act like walls that hold it in place. Sometimes smaller storms merge into it and give it a boost. Sometimes chunks peel off its edge. It looks calm from far away. But inside that oval, the air screams around in loops that never end. Jupiter's storms aren't just big. They are energetic. There is lightning inside the deep water clouds that carries more punch than most lightning on Earth. There are quick flashes high above storms that look like rings and jellyfish, nicknamed sprites and elves. They happen when strong lightning changes the thin air near the top of the atmosphere. And there's that mushball idea. In the mix of water and ammonia, cold and heat and rising air can make slushy hail. Those mushballs fall and drag ammonia down into deeper layers. That can help explain why the upper air sometimes looks short on ammonia. The storms are not just moving air around. They are moving chemicals up and down like an invisible elevator. Because Jupiter spins so fast, the whole planet bulges at the middle. It's not a perfect sphere. It's a little squashed, wider at the equator than from pole to pole. That fast spin also shifts how we measure the day. Different latitudes spin at slightly different speeds. Astronomers use radio pulses tied to the magnetic field as a more steady clock, because the clouds drift and don't spin as one solid shell. Nothing on Jupiter behaves like a solid shell. It's a fluid world, from top to almost bottom. Now let's zoom out and talk about how this giant affects everything else. The story that Jupiter protects Earth by deflecting comets is half right. Sometimes it does, sometimes it doesn't. Jupiter's gravity can flick incoming comets and asteroids away. It can also pull new ones into paths that cross the inner planets. It's both shield and slingshot. The scars on Jupiter itself prove how often it gets hit. In 1994, a comet named Shoemaker-Levy 9 broke into pieces and slammed into Jupiter's south. We watched the dark bruises spread across the clouds for months. In later years, we saw other impacts splash up scars as big as our planet. Jupiter takes a lot of hits for the team, but it also stirs the pool that sends new rocks flying inward. The net effect depends on the mix of objects and their paths. The point is simple: Jupiter matters. Take it out, and the statistics for impacts in the inner solar system change. That can change the odds for life. There's more evidence of Jupiter's reach in the two swarms of asteroids that share its orbit, one ahead and one behind. These are the Trojan asteroids. Jupiter's gravity creates special safe zones 60 degrees ahead of it and 60 degrees behind it, where small bodies can gather and stay. These groups are like time capsules. Some may be dark, primitive objects from the early days. Studying them helps us understand what the building blocks of giant planets look like, and what raw materials were flying around when Earth formed. Jupiter also wears a ring, though most people never hear about it. It's faint and dusty, not like Saturn's bright icy rings. The dust comes from small impacts on tiny inner moons. The ring shows that even a giant can have delicate features. It's a reminder that Jupiter is still a work in progress, constantly hit by small grains that make and rebuild that ring. Let's go back to the moons, because you can't explain Jupiter without them. Think of the four big ones as four very different labs. Io is wild. It is the most volcanic body we know. Its surface is a patchwork of fresh lava fields, sulfur plains, and tall plumes shooting gas into space. Why so active? Tides. Jupiter's gravity pulls on Io. The other moons pull too. Io's orbit gets stretched and squeezed. That constant flexing heats it up inside. The way bending a paperclip back and forth makes it warm. The result is volcanoes everywhere. The gas that comes off Io feeds a great donut-shaped cloud of charged particles around Jupiter. those particles get trapped by the magnetic field and race around the planet. They add to the radiation that makes the space around Jupiter so harsh. Europa is calm on the surface, but may be lively inside. It's a bright ice world, marked by long, reddish lines that look like cracks. The best model says there is a liquid ocean under the ice. How? The same tidal flexing that heats Io also warms Europa, but less. That heat can keep water liquid under the shell. Water plus energy plus a rocky seafloor could make a place where chemistry runs for a very long time. That is why Europa is one of the best places to look for life beyond Earth. Not fish and trees, simple life. But even that would be huge. Jets of water vapor may sometimes blow from cracks near the surface. If those jets are real and we can fly through them, we can test for salts and organics without drilling. That's a big deal. Ganymede is the largest moon in the solar system. It's bigger than Mercury. It has its own magnetic field, which is rare for a moon. That means something inside is moving and conducting electricity. Maybe a liquid iron core like Earth's, maybe salty water layers that flow. Its surface shows old, dark areas and younger, brighter streaks. It might also hold a deep ocean sandwiched between ice layers. Ganymede is a giant in its own right, a full world with complex layers. Callisto is the quiet one. It's covered in craters, old and steady, a record of billions of years of hits. It seems less altered inside, more like a frozen mix of rock and ice that never melted much. It may also have a hidden ocean, but if so, it's deep and quiet. Callisto stands at the edge of Jupiter's main zone, almost like a small planet that never took the next step. Together, these moons act like a clock and a motor. They tug on each other in a rhythm that keeps their orbits slightly stretched. That stretch means tides. Tides mean heat. Heat means activity. And that activity feeds gas and dust into the space around Jupiter, which the magnetic field then grabs and whips into belts. If Jupiter is a machine, the moons are the gears. Spacecraft turned ideas into hard numbers. Early flybys gave us our first real close-ups. Later, an orbiter mapped the system and found things nobody expected, like how strong the radiation zones are and how thin the ring is. Recent missions took a hard look at Jupiter's gravity and magnetism and found proof that the jets go deep, the core is fuzzy, and the ammonia is uneven in ways that point to storms carrying it down. These weren't small updates. They forced us to accept that the inside is more mixed, the weather is more three-dimensional, and the chemistry moves in loops that break the neat layer cake picture. All of this changes how we see giant planets around other stars. We know now that gas giants can move in their birth disks. We've found many hot Jupiters around other stars, giants that sit very close to their suns. Ours didn't end up that close, which is good news for us. But learning how our Jupiter formed and how it behaves helps us read those distant systems. It gives us a way to guess which of those systems might have small, rocky planets in safe lanes, and which ones were bulldozed by a wandering giant. There's a detail I don't want you to miss. Jupiter is loud in radio waves. Its magnetic field spins and the field lines snap and hiss with charged particles. When its moons move through those fields, especially Io, with all that gas, it sets up electric currents that scream in radio. If you tune the right gear at the right time, you can hear Jupiter. In radio, that's the sound of a giant magnet in action. That energy is why the area around Jupiter is so tough on electronics. If you send a probe there, you shield it like you would shield a vault. And yet, for all its power, Jupiter carries small, delicate signs of structure. There are oval storms that drift for years. There are thin filaments that twist out of big storms and then snap back. There are little white storms that pop up, merge, and fade. Sometimes an entire belt fades to pale, then bursts back to dark, as deep plumes of hot gas rise and change the weather above them. Think of a pot where the heat from below is patchy and the pot is spinning very fast. You would see long, stable streams with sudden bursts. That's Jupiter. It is both steady and twitchy, and it will be like that for a very long time. So when does this all click? It clicks when you stop seeing Jupiter as a picture and start feeling it as a system. Inside, metallic hydrogen, helium rain, a fuzzy core. Outside, deep jets, storms that move chemistry around, lightning that hits like a hammer, a red storm older than our telescopes. Around it, moons that pull and heat and feed the space around the planet, a faint ring of dust, a pair of asteroid swarms riding along like bodyguards. Farther out, a solar system whose shape was set, in part, by this one giant. Impacts deflected, impacts delivered. Water and rock mixed and moved. A path opened for a small blue world to form and keep the right distance from danger. That is Jupiter's real story. Now picture standing somewhere dark on Earth on a clear night. You look up and see a bright, steady point that doesn't twinkle much. That's Jupiter. If you looked at it with a cheap telescope, you would see a little disk and maybe those moons. Each of those dots is a whole world. The light from Jupiter is sunlight bounced back off clouds made of ammonia, ice, and other stuff. But part of what you can't see is that Jupiter is glowing in invisible light. In heat, it makes itself. It is still cooling down, still settling, still running. There's a reason cultures gave Jupiter the name of a king. Not because it's pretty, though it is, because it commands. It holds moons in chains the size of mini solar systems. It grabs comets and throws them into new paths. It shouts in radio. It paints the sky over its poles with lights far brighter than ours. It is not a silent ball. It's a planet that acts like a living engine. We don't need fancy words to get this across. The simple facts are enough. Jupiter formed early and fast. It got massive. That mass turned hydrogen into a metal-like liquid deep inside. That liquid helps drive a magnetic field that traps energy and shapes space around the planet. The planet spins fast and bulges at the belly. Jet streams wrap around in bands. Storms rise and sink, move chemicals up and down, and spark lightning. A giant red storm spins like a tire track stamped on cloud for centuries. 4 big moons pull and heat each other and build a rhythm that never stops. The whole setup shapes the solar system in ways that reach far beyond Jupiter's orbit. We know this not just from ideas, but from probes that have flown there, orbited there, and measured the details. If you want a single key moment, here it is. It's the point where you realize that Jupiter doesn't just live in the solar system, it runs it. When a comet hit Jupiter and left black bruises bigger than Earth, we saw with our own eyes what it means for a giant to take a punch. When we mapped the gravity and found the fuzzy core, we saw that even the deepest part is not a neat sphere, but a blend. When we traced the jet streams down and felt the tug of deep winds in the gravity data, we learned the weather is not skin deep. When we saw hints of water oceans under ice on Europa and a magnetic field inside Ganymede, we learned that just one planet's family can hold many kinds of worlds, some of which may be friendly to simple forms of life. That's the flip. Jupiter stops being a big ball and becomes the backbone of the system. So the next time someone says, Jupiter is the big one with the red spot, you'll know why that falls short. You'll be able to say, it's a heat source, a magnet, a slingshot, a shield, a wrecking ball, a weather factory, and a whole school of worlds tied to one giant. You'll know that its inside is weird, in the best way, hydrogen acting like metal, helium raining out, a core that's a zone, not a rock. You'll know the belts and zones are not just looks, but deep rivers of air. You'll know the red storm is only one chapter in a long, loud book. You'll know that Earth's safety, Earth's water, and even Earth's place in the line owe something to the timing and weight of that giant far away. And you'll also know this: we still have questions. How exactly is the heavy stuff mixed inside? How stable is the red storm over the long run? How often do those belts flip from faint to dark and back? And what sets the timing? How salty is Europa's ocean? How thick is the ice? And does anything swim in the dark there, microbes clinging to warmth near vents at the sea floor? How is Ganymede's field sustained? What quiet secrets does Callisto keep under its ancient crust? The answers to these questions aren't trivia. They feed back into the big picture: how planets form, how they move, and how many Earth-like worlds might stand a chance around other stars. But for today, you've got the core idea. Jupiter is not a side character. It is the reason the solar system looks the way it does. It isn't sitting still. It is running hot inside, roaring with a giant magnetic field, wrapped in deep winds, and circled by worlds that each tell a part of the story. If you've ever felt like space is too big to grasp, hold on to this one truth: one planet can set the stage for all the rest. On our stage, that planet is Jupiter.